Know Your IS Code Provisions short lecture series. In today's short lecture, I will explain about factors affecting response of structures to earthquake ground motion. So there are several factors which affect the response. One is structure itself, type of structure. Then second one can be the type of foundation. And third, the soil type. And then the ground motion itself, the characteristics of ground motion. All these things affect response of structure. Now, what are the code clauses so which are given and what are the limitations and conditions stated therein? So let's go into the details. Yeah, so the clause number 6.1.2, that is factors affecting response of structures. So the response of a structure to ground vibrations depend on, that is type of foundation, materials, form, size, mode of construction of structures, and the duration and characteristics of ground motion. So let us look into the details of one by one. So what does it indicate by type of foundation? So if we look at, say, type of foundation, there are two broad categories, that is shallow foundations and deep foundations. So some types of shallow foundation, that is individual footing, combined footings, strip, raft or mat, etc. So there can be many other shallow foundation types. So this foundation type affect the response of structure to ground motion. And in deep foundations, we have piled foundation like caissons, etc. So whatever is the type of the foundation, that also affects the response of the structure to given ground motion. The second one, material, form, size. So let's look into those details. So materials, say concrete, steel, masonry. These are the types of the materials. So which each one has a different kind of stress-strain relationship, and combined with say like cross-section and then elements and the entire structure. So concrete structure and steel structure, masonry structure, depending on the material used, behavior can be entirely different. Then coming to the form. So what is the structural form adopted, okay, in the design, for the design? And the size. Size means like aspect ratio of the building, elevation, profile, like plan, all those things also affect. Then mode of construction. So what is that monolithic construction, precast, prefabricated, all that kind of things. So all these things come under the second category, that is materials, form, and mode of construction. So coming to the third one, that is duration and characteristics. So mainly the characteristics of earthquake ground motion. So there are three characteristics of earthquake ground motion. So this was discussed in 6.1 lecture. So we can look into the details of that lecture. And so in short, what are the characteristics of earthquake ground motion? Amplitude is one character, duration is another character, and the third one is frequency. So when it comes to amplitude, so we say PGA, PGV, and PGD, peak ground acceleration, peak ground velocity, and peak ground displacement. Now, it happens that, say, a building, say the two, let's take two amplitudes, say like say 16G, some earthquake, and the same earthquake, or another earthquake has peak ground acceleration of say 0.18G. So if all the conditions are same, definitely 0.18G earthquake will cause more damage compared to 0.16G. But if the duration of 0.16G peak ground acceleration earthquake is more compared to 0.18G, then because of the number of inelastic cycles which structure make, damage will be more in the second one. That is, even the peak ground acceleration is less. So that's how these two are connected. Not alone peak ground acceleration, but also the duration of strong ground motion is also important. In addition to these two, there is another thing. So structure has peak ground acceleration, more peak ground acceleration, also more like a higher duration of strong ground motion, say 0.116 g peak ground acceleration, say duration of strong ground motion is say 45 seconds. But there's another earthquake whose PGA is say less, even less, say 0.14 g only, and the duration is also slightly lesser, say 30 seconds only, but it has frequency which is nearly matching with the structure's frequency. In that situation, the third earthquake will cause more damage compared to the second one, and the second earthquake causes more damage compared to the first one. So that means these three things are connected. So we need to understand the amplitude of ground motion and duration of strong ground motion, and also the frequency content present in the ground motion. So if frequency content is nearly or the structure's predominant frequency is coming in the band of predominant frequency of the ground motion, then more damage will occur. So now these three things, the response of structure to ground vibration depends on foundation, form and materials and type of construction, and also characteristics of earthquake ground motion. Then the other important statement which code makes is this standard, that is 1893 part 1. So this standard specifies design forces for structures founded on rocks or soils which do not settle. So that means stable soil, and then which do not liquefy or slide due to or lateral spread. So slide due to loss of strength during earthquake ground vibration. So that means what? More soil should be stable. That is the condition in which the clauses of this code have to be used. So liquefaction is another issue. That is simplified procedure for liquefaction potential assessment is given in the annexure of this code. So we can like you can study. There is a short lecture on that also. So this code says that the soils which do not settle and which do not liquefy or which do not slide. So all these three conditions are there. Or soils which settle and liquefy or slide, they are not, the clauses of this code are not valid for that kind of structures. So more to the stable kind of say rocks or soil which do not settle. So the intention of this short lecture is to help students and early practicing engineers to understand IS code provisions in a better manner. So, thank you.